10.4, I'm going to review a little bit of what we did Friday so that we move into the new stuff. We bring back into our remembrance. We defined the logarithm to be y equals log base b of x is equivalent to b to the y equals x. This is going to help us be able to essentially work with the logarithm. How I move from logarithm to exponential and exponential back to logarithm notation when we solve equations is going to be important that we be able to write our logarithms both ways, both as a log and as an exponential. We basically said that it is the inverse of the exponential function, so it's the undo button, which means that from x to y, b to the x takes domain to the range, and then log, the same base as the exponential, will bring it back. The domain of the exponential is all real numbers, and then when we graphed it, we saw the range was 0 to infinity. And then the range of the exponential is 0 to infinity. And that means when the logarithm comes back, the logarithm only has numbers that I can put in for x between 0 and infinity, and then its range is all real numbers, as you're going to see when we start graphing it. So it is the inverse of the exponential function. The most important thing that we're going to be doing in order to work with this stuff, and if you can't do this, you probably are going to be killed on this last exam, is that you need to be able to move from log notation to exponential notation and from exponential notation to log. 90% of the time, we're going to be going this direction. We're going to turn a logarithm into an exponential because we know how to solve exponential equations. So this is about 90% of the time. And then we use this for equation solving. And then this would be about 10%, even or less of the time, we go from exponential to log. So when I look at going from an exponential function to a log function, this is what I kind of note to myself. I have the log. I have a base. I have the thing I'm taking the log of. And I have a result. So by the way, this thing right here, just like a radical has a radicand, we call this thing the argument. So if I were going to take, as for example, 8 equals 2 to the x, and write it as a log, I'd have the log, I'd have the base, I'd have the argument, the thing I'm taking the logarithm of, and I'd have the result. I have 3 things. I have an 8, a 2, and an x. They all have to go someplace. Good news is the base is the base is the base is the base. So the guy that holds the exponent is the base, so this guy would be base 2. Then I have a 50-50 chance of placing the 8 and the x in the right place. Well, if you got to remember that the logarithm picks up the range and returns it to the domain. 8's a range value. And then that leaves the x. It's the domain value. So if I look at 8 equals 2 to the x, it's equivalent to log base 2 of 8 equals x. Now, to me, when I look at going from a logarithm to an exponential, I just unwind it. Here's the base. I raise it to the y power, and it's going to be equal to what's going to be on the inside. So in this case, I am going clockwise. The base, power, what it's equal to. So if I have, in this particular instance, A is equal to log base B of D, here's my base. So I start at the base. B to the A is equal to D. So the equivalent form is B to the A is equal to D. This you have to know how to do in your sleep, because that's the guy you're going to be using over and over and over and over and over and over and over again. Moving between notations.